Hello, 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 hello. Here we are again for another psychology video. Got my little pointer ready. Quite a short one today about what we mean by levels of data. Now, this is something that you will come across in a big way in Year 13 research methods, but it ties quite nicely in with what we're doing at the moment in terms of measures of central tendency and the stuff that we're going to do on graphs next lesson. So it's useful to know what we mean by these levels of data, and that's what we're going to do today. So we're going to be talking about nominal, ordinal, and interval data. This is what the specification says that you need to know in terms of your exam. Okay, so there are different ways in which data can be collected, and there are different ways in which those measurements can work. We tend to divide them into four types: nominal, ordinal, interval, and ratio. Now, in terms of the exam, they don't require you to know ratio, okay, because it's very, very similar to interval. So actually, what you need to know is nominal, ordinal, and interval. But I am going to talk about ratio data as well because it makes a nice little acronym to help you remember, which is noir, which, for those of you who remember your French, is black. Don't know why that helps to remember it, but it spells noir. So nominal, ordinal, interval, ratio. The simplest measurement is nominal, and then ordinal, interval, and then ratio. We'll go through there's a basic explanation there, but we're going to go through it in more detail now. You might find it useful to pause the video if you want to make notes. I suggest you do make notes because, as I say, you need to be able to spot all of this stuff. And then at the end of the lesson, or at the end of the video, I'm going to put a quiz on the classroom, as is the new standard, so you can show off everything that you've learned in this. Okay, so if we start with nominal data, um, basically nominal data is data that falls neatly into named categories. So think of the French nom. French again? Are you serious? Yeah, I am. If you think the French for name is nom, if you don't remember any French or you never studied French, that's no help. Just think nom sounds a bit like name. Um, so it's named categories. So, for example, fruit. You might have berries, bananas. These are all categories. These are all names. It's the least. I don't know where am I going with that. I'm losing it. It's the least precise form of data because you just simply count up the frequencies of the number of times a particular data is used. So for nominal data, we normally use the mode as our measure of central tendency. And for those of you who last lesson when we were doing measures of central tendency, you were probably sitting there thinking, why would anyone ever use the mode? The mode is a rubbish way of working out an average. Well, sometimes we have to use the mode, and we have to use the mode when we're using nominal data. So when data falls into categories, we use the mode as our measure of central tendency because we can't use any of the others. I'll give you an example. If I was interested to find out how tall everyone who takes psychology is, I could create categories and I could say, right, you lot are all short, so I'll put you in the short category. You lot are about average, so I'll put you in the average category, and you lot are tall. And then when I'm working out the average, I can't get a mean of these categories. So I have to just count who has fallen into the categories. And look, oh, there's 6 people in the average category. Therefore, the average would be average. So I'd have to use the mode. So nominal data is data which falls into categories. So again, for instance, if I was looking at eye colour, that would be nominal data because it would fall into categories. If I was doing the strange situation, that's nominal data because you are going to be named either insecure avoidant, insecure resistant, or secure. I hope that makes sense. Okay, so that's nominal. The next form of data is ordinal. So another thing I could do with data is I could rank people depending on the score they got. This is common when people are taking tests. So you assign them a rank from highest to lowest. Now, for instance, if I had 10 participants and I gave them a test, say a memory test, and then I would say, okay, the bottom score gets rank 1, and then 2, 3, 4, 5, 6, 7, 8, and the top score would be 10. And once you're given a rank score, the problem that we have is that the gaps between 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are not all exactly the same size. So, for instance, the gap between whoever comes bottom and second to bottom might be 5 on the test, but the gap between second and top might be 15. So the gaps are all of different lengths, and this is common when you're taking a non-standardized test. So all we can do really is to put them in order and use that as our measure. And when we do that, we would most commonly use the median in order to get our measure of central tendency. And it doesn't tell us, the median, how the grades are dispersed, because we don't know the gaps between each one. For instance, like in a running race, you know, if Usain Bolt wins the 100 meters, does he still run? Usain Bolt, probably retired now, isn't he? I need to get more up-to-date references. But if he did, and he won the race, he would come first, and the person who came second would come second, and then someone would come third. But we don't know the gaps between those. We just know first, second, and third: gold, silver, and bronze. We just know that Usain Bolt was the fastest. So we might use the median to work out as the average, and we would use the range as a measure of dispersion within that. So that's all data. Again, if we're doing this in height terms, I could line everybody up in our class, and you know, you're the shortest, so you get 1. You're the tallest, you get 12. So my median is going to be 6.5. So my average is going to be somewhere between these two people. That'll be my average height. And my range would be between the top and the bottom. Now, the quote best form of data, or the one that we're going to be most confident in using, would be interval data. Now, interval data is when you're using a standardized units on a internationally recognized scale. The way we can tell interval data is that the gaps between each of the measurements is always exactly the same. So when I talk about like a recognized scale, things like height would be measured using centimeters or inches, something where the gap between each unit is exactly the same. Other examples could be weight, temperature. IQ tests tend to be standardized with the same gaps between each measurement. So that's what we mean by interval data. Now, in terms of the exam, you just need to know interval data. But I did mention ratio data at the start. Ratio is just a form of interval data, but you can't sink lower than a 0 on a ratio scale. So, for example, temperature is an interval scale because it can go to -10. Whereas something like height is a ratio scale because you can't get shorter than 0. So ratio is considered slightly better because it doesn't have the problem of dropping below 0. So, for instance, with temperature, the gap between 10 and 30 is not the same as the gap between 10 and -10. It's not because you've got that problem of going below 0. Anyway, so ratio is considered purest because it starts at 0 and moves up from there, with each gap being exactly the same length. So if, for instance, you were timing the amount of time it took a rat to run a maze, that would be a ratio scale. But in terms of your exam, you can call it interval because that's the term that you're going to use. It's interval data. We know that the rat that ran it in 47 seconds was, exactly 3 units faster than the rat that ran it in 44. The beauty of interval data is we can now use the mean as our measure of central tendency. So we can add all the rats up and divide it by the number of races they had and get the average amount of time it took them to run the race using the mean. And it also means, because we've got the mean, we can now use standard deviation to measure the dispersion, which means that we're using much more precise measurements now. So that's interval data. Now, next lesson, we're going to talk about how nominal, ordinal, and interval data all use slightly different graphs to plot them. That's something else you need to. So back to my height example. If I was interested to know how tall everyone was in psychology, I would measure them. So this dude here is 134 centimeters, and this dude here is 185. I can then measure each and individual person, add them all up, divide them by 12, and I would get the mean height. And then I could use standard deviation to work out how dispersed people are from the mean. And judging by this photograph's a drawing. What am I talking about? This picture. Most people are going to be sort of falling in this area here. One standard deviation from the mean, about 65% of our crew there probably falling in that. Okay, and that is the end. So there are different levels of measurement when we're talking about sort of types of data. So in summary, not all quantitative data is as good as each other. If I had to ask you all, oh, what's your favourite soft drink? And you went Coke, Dr. Pepper, Coke, Mountain Dew, Fanta. That would be nominal data. These are all named categories: Coke, Fanta, Dr. Pepper. And I would count out frequency and say, oh, 8 of you said Coke. So, most people like that. That's the average drink. But that would be a mode, nominal data. Ordinal data, putting things in a rank, in an order. So, for instance, I might say, I might be doing something about attractiveness, for instance. Here's a picture of 10 celebrities, put them in order of most attractive to least attractive. Or any questionnaire when you have one of those Likert scales, strongly agree, disagree, that would be an order, ordinal data. On a scale of 1 to 10, how do you feel about? Now, the gaps between those things are not standardized. So, my attractive celebrities, the gap between 1 and 2 is not going to be the same as the gap between 9 and 10. It might be, but it won't necessarily be. And then we've got interval data at the end, where we're using an internationally recognized scale where the intervals, the gaps between each unit, are exactly the same length. So I hope that makes sense. They're the types of data that we're going to be doing. I want you to make some notes on those so you can go back. I'll put a copy of the PowerPoint on the classroom as well. And then I'll ask you to sit a little quiz about it. Okay. I hope that makes sense. I hope that's been useful. I will see you all for another video about graphs next lesson. Bye now.